Hello everyone, welcome to the new video. So in this video we are going to solve some sums on NFA. So this is the first question which says that to design an NFA with sigma equals to 0, 1 and accepts all strings ending with 0 and 1. So let us write the language first. So the language for this is all the strings ending with 0 and 1. So 0 and 1 ends with 0 and 1. 0, 0, 1 ends with 0 and 1. 1, 0, 1 ends with 0 and 1. 0, 0, 1, 0 ends with 0 and 1. Sorry, 0, 1 ends with 0 and 1. Else 1, 1, 1, 0, 1 ends with 0 and 1, and so on. So now we'll draw the transition diagram for this. So if we are having the minimum states as n, then we need to have n plus 1 states. So the minimum length of the string what we are having is 2. So number of states what we have should do is 2 plus 1 is equals to 3. So in total we need to have 3 states. So let our states be q0, q1 and q2. So let q0 be our initial state and q1 be one of the states, and let q2 be the final state. As all the strings are ending should end with 0 and 1, so 0 and 1, so we achieved this one, that is 0 and 1. So 0, 0, 1. So if q0 has 0, 0, 0, 1, we have achieved this. Next one is 1, 0, 1. So for 1 also it goes on a self loop. So 1, 0, 1. So through this transition diagram we can see that all the strings which end with 0 and 1 are accepted by this. Let's go for another example. So what they are asking is design an NFA with sigma equals to 0, 1 in which double 1 is followed by double 0. Cool. So double 1 and followed by double 0. And we don't care what we have here and we don't care what we have here. It is to the sides of it. So the language what we can write is double 1, double 0 is the one thing, and also we can have 1, 1, 1, 0, 0 and another 0, or 1, 1, 0, 0, 1, 1 and so on. So let us check out how many states we need for this. So the minimum length of the string what we have here is 4, that is our n is 4, so we need to have n plus 1 states. So 5 states. So let our states be q0, q1, q2 and q3. Sorry, and also q4, as we have 5 states. So q0 be our initial state, and then q1, and then q2, and then q3, and finally q4 is our final state. So all the strings should have 1, 1, 0, 0, right? So in this way we got the first one, that is 1, 1, 0, 0 and 1, 1, 0, 0. So we'll put a self loop on this saying if it has 1, take it. That's the last example says 1, 1, 0, 0 and also 1. In the same case, we can also have another string which is like 0, 1, 1, 0, 0. So here it is starting with 0. So it can also be 1, 0. And also we can have another string which is like 1, 1, 0, 0, 0. And here 0, it is ending with 0 again. So we can also have another 0 here. So in this way we can get all the strings which are having double 1 and followed by double zeros. Let's check out another example. So here they are asking us to design an NFA with all string contains 1110 as its substring. So a 1110 as a substring means we don't care what we have here, and also we don't care what do we have here. So the language what we can write is 1110 is the basic one, or 1110 is another one what we can do, or sorry, or the other thing what we can do, or 0, 1110 what we can have, or 1110 and followed by a 0. Else we can also have 0, 1110 and also ending with 1. So the minimum length of the string what we are having here is 4. That is n is equals to 4. And we need n plus 1 states. So in total we need to have 5 states. So let our 5 states be q0, comma q1, comma q2, comma q3, comma q4. So let us have all our states now. So let q1 be our initial state, followed with q2, followed with q3, sorry, q0 is our initial state here, I'm so sorry, and q3, and finally q4 is our final state. So we are having 1110 and also 1110 as a first string. So 1110, this is accepted. What if we have an 1 before it? So we'll just do a self loop. If we are having 1, this is also done. What if we have a 0 before it? Okay, we'll put a 1 comma 0. So even if we have a 1 comma 0, it is accepted. What if we have 1110 and ending with 0? We'll put a self loop for this, saying if it got a 0, do it. So done. And what if it's ending with 1? 1110 and also 0 and also a 1. So this NFA diagram accepts all the strings which has a 1110 as its substring. Let's check out another example. So here what are they saying is design an NFA with sigma is equal to 0 comma 1 accepts all string in which the third symbol from the right end is always a 0. So it is a third symbol means 1 2 3. This symbol should be always a 0, and we don't care what is here and also what is here. So the language what we can write is 0 1 1. Third symbol from the right is always 0. Also we can also have 0 0 0. Here also the third symbol is 0, and we can also have something like 1 1 0 1 1, and it is also having a 0 as its third symbol. Else we can have 1 1 1 0 0 0, or so on, because here also the third symbol is 0. So let us draw the transition diagram for it. So the number of states what do we have here is 4, because n is equals to 3 and n plus 1 is equals to 4. So 4 states. Let our 4 states be q0 as our initial state, q1, q2, q3, and finally q4 as our final state. So minimum string what we want is sorry, I drew 4 strings, so this would be a final state, I'm so sorry. So we are not having this. So 0 1 and 1. So we got this. What if we have 0 0 0? What if we are having 0 and a 0 and a 0? So 1 comma 0 1 comma 0. So 0 0 0, this thing is also accepted. What if we are having 2 ones before it? I just put a self loop on it, saying if you got 1, do a self loop. So 1 1 0 1 1. And lastly, what if we are having a 1110, or this thing also is like 1 1 1 0 0 0? This thing is also accepted. What if we are having something like 0 0 0 0, like 4 zeros, and the third symbol is 0? This is also accepted, right? So 1 comma 0. So if you are having zeros also, it's accepted. So this NFA accepts all the strings which are having its third symbol as 0. I hope you understood how to design NFA. Thank you.